Right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system. It's a comet, now named 3I Atlas, and it's only the third object ever confirmed to have come from interstellar space.
This is a raw image, so this is not even this is just directly from the telescope right now.
You're looking at a piece of what would have become a planet in another star system. This is a building block from somebody else's home.
The James Webb Space Telescope just confirmed something approaching Mars at 58 kilometers per second, an interstellar comet 7 billion years old, twice the age of our Sun. 3I Atlas will pass within 28 million kilometers of Mars in early October 2025. Webb's observations revealed chemistry that shouldn't exist, and every space agency with equipment at Mars just repositioned their instruments to watch what happens when this ancient visitor reaches the red planet. What Webb detected changes everything. Carbon dioxide levels exceeding anything ever measured in a solar system comet. When Webb locked onto 3I Atlas on August 6th, the readings showed concentrations suggesting this object formed somewhere completely different from our stellar neighborhood. Water ice appeared in the spectrum, water vapor, carbon monoxide, carbonyl sulfide. But the ratios made no sense. Nothing matched what comets are supposed to look like. 3 weeks later, the Very Large Telescope in Chile added another piece. Cyanide gas in the coma expected for active comets. Then atomic nickel vapor at concentrations never recorded in any database. Nickel without iron. The metallurgy belonged to a planetary system 7 billion years gone, from a star we'll never see. NASA's SphereX observatory tracked the carbon dioxide plume from August 7th through the 15th. The gas extended 350,000 kilometers from the nucleus. At that distance from the Sun, solar winds should have compressed it, confined it. Instead, it kept expanding, growing, defying physics that govern every other comet ever observed. SphereX found something else. Structure within the plume. Not random expansion, but organized patterns suggesting multiple active regions on the nucleus surface. Carbon dioxide distribution didn't match water vapor distribution. Compositional variations across the surface. This heterogeneity suggested the nucleus formed from materials gathering under varying conditions, perhaps at different distances from its parent star. Lowell Observatory detected cyanide at concentration levels matching solar system comets, but the ratio of cyanide to other carbon molecules skewed toward values never recorded. Each observation added complexity. Each measurement painted conditions completely alien to our stellar neighborhood. Then came the mass calculations. Harvard astrophysicist Avi Loeb and his team analyzed trajectory data from May through September. Comets accelerate from outgassing. Ice turns to gas. Jets push against the nucleus, nudging the comet off course. Every active comet ever observed shows this acceleration. 3I Atlas showed almost none. Gas pouring off the surface, dust streaming into space, but the trajectory barely budged from what gravity alone would produce. Only one explanation fit: enormous mass, at least 33 billion tons. A nucleus measuring 5 kilometers across or larger. That size made 3I Atlas 10 times larger than Borisov, the previous interstellar comet. Objects that massive shouldn't be common enough in interstellar space for us to stumble across them this easily. The Atlas survey only achieved full capability in recent years. Perhaps smaller interstellar comets pass through regularly but remain too faint to spot. Perhaps 3I Atlas represents just the tip of a population of wanderers cruising through our solar system unnoticed. But there's more. The trajectory. The comet's path aligned with the ecliptic plane, the flat disk where planets orbit the Sun. The probability of that alignment happening by chance. Roughly 1 in 500. Either 3I Atlas got extraordinarily lucky in its approach angle, or something about its origin favored this particular orientation. A deliberate path through the planetary plane, as if following a route mapped billions of years ago. Early October 2025 marks something unprecedented. 3I Atlas reaches its closest point to Mars at 28 million kilometers, the closest any confirmed interstellar object has ever come to another planet while humans watch. But the timing raises questions nobody wants to ask out loud. The alignment falls on astronomical resonance dates studied by ancient civilizations, orbital harmonics occurring in cycles of 54 years. The last time inner planets were in similar positions during a comet passage, the Tunguska event in 1908. This synchronicity sent shockwaves through the scientific community. How could a random interstellar object arrive at such astronomically significant moments? Unless it wasn't random, unless it was timing itself, following a clock not built by human hands. Every Mars orbiter coordinates for the encounter. ESA's Mars Express and ExoMars Trace Gas Orbiter turn their instruments toward deep space. The comet appears as barely more than a bright point, but the instruments target something beyond pictures. Mars Express carries spectrometers called Omega and SpyCom. ExoMars has Nomad. These instruments capture composition data from a vantage point 270 million kilometers closer than anything Earth-based can achieve. NASA's Mars Reconnaissance Orbiter joins with HiRISE, resolving features 30 kilometers across. The different viewing angle could resolve the size ambiguity plaguing observations. The Perseverance rover carries SuperCam, analyzing atmospheric composition. Mission controllers program observation sequences attempting to detect trace molecules from 3I Atlas reaching Mars's upper atmosphere. Probability remains low, but the payoff would be extraordinary. Direct sampling of interstellar material without leaving the planet. Curiosity's ChemCam receives similar programming. Both rovers turn their cameras skyward during closest approach. The photographs might show little more than a faint smudge, but they represent the first time humans capture an interstellar visitor from another planet's perspective. The coordination took weeks of planning. Engineers calculated precise pointing angles for spacecraft designed to look down, not up. Communication delays meant commands, uploaded days in advance, with flexibility accounting for uncertainties in the comet's exact position. But there's another reason for the coordination. The Mars encounter provides triangulation. Earth sees 3I Atlas from one angle. Mars sees it from another, separated by tens of millions of kilometers. Precise measurement of the comet's three-dimensional structure. Gas distribution patterns that might reveal whether this visitor behaves like comets are supposed to. The composition data matters because of what 3I Atlas represents. A messenger 7 billion years old, twice the age of our Sun and solar system. The comet potentially orbited its parent star for billions of years before some gravitational interaction ejected it into interstellar space. Then it drifted through the galaxy. Cosmic rays bombarded its surface. Interstellar dust impacted at kilometers per second. The background temperature of space, just degrees above absolute zero, locked its chemistry in frozen stasis for eons. The journey left marks scientists hope to identify. Cosmic ray exposure creates specific isotopic signatures in surface materials. Prolonged exposure to interstellar radiation alters organic molecules differently from solar radiation. Spectroscopic observations detecting these signatures would constrain how long 3I Atlas spent drifting between stars. Now, approaching the Sun for possibly the first time in billions of years, ice subliments. Gases that may have stayed frozen since before Earth existed pour off the surface. Every molecule detected represents a data point about the chemical environment where this comet formed. The carbon dioxide richness might indicate formation in a particularly cold region of its home system. The nickel signatures could reveal how planets formed in that distant system. Different ices sublimate at different temperatures. Water ice stays frozen until warmer than carbon dioxide ice. Carbon monoxide sublimates at even colder temperatures. By tracking which gases appear at which distances from the Sun, astronomers map the layering of ices in the nucleus. Reading the history of how this comet gathered material in its birth environment billions of years ago. But there's a question nobody wants to ask out loud. What if the trajectory calculations are off? What if 3I Atlas doesn't pass Mars at 28 million kilometers? What if something changes? The math is straightforward. 3i Atlas weighs at least 33 billion tons, moving at 57 kilometers per second relative to Mars. If trajectory calculations miss by even a fraction, if outgassing creates unexpected acceleration, if any variable shifts, the impact would unleash energy measured in millions of megatons. The crater would span 60 kilometers wide, 5 kilometers deep. Debris scattering across Mars' orbit, some ejected into interplanetary space, some potentially reaching Earth years later. But physical destruction tells only part of the story. Mars hosts dozens of scientific assets: rovers, orbiters, experiments searching for life, climate records spanning decades. An impact wouldn't just destroy machines. It would erase decades of research, blind communication arrays, potentially ignite contamination events humanity is wholly unprepared for. ESA, Roscosmos, CNSA, JAXA have all initiated planetary defense discussions. Not against an alien fleet, against a single object behaving just slightly outside expected parameters. Mars might harbor life deep beneath its surface. Subsurface lakes, dormant microbes, ancient ecosystems locked beneath permafrost. The extreme heat of impact wouldn't just vaporize the surface. It would crack open deeper layers of Martian crust, exposing reservoirs never reached. And if 3i Atlas carries organic molecules embedded in its outgas trails, the fusion of interstellar chemistry with potential Martian biology could result in contamination on a planetary scale. Some biologists call this panspermia in reverse. Not life spreading from Mars to Earth, but life being seeded into Mars. What if the goal was never destruction? What if this object is a delivery system and Mars is the recipient? The probability remains low. Trajectory calculations show a safe passage. But the mass anomaly, the unusual chemistry, the aligned trajectory, the astronomical timing all suggest this visitor doesn't follow rules astronomers are used to. In space, low probability events happen with regularity given enough time and enough objects. Then there's something nobody expected. The trajectory of 3i Atlas crosses a narrow corridor passing directly above Elysium Planitia, a geologically young region of Mars known for unusually symmetrical surface features. Satellite imagery revealed concentric ridges, spiral-like flows, formations mimicking natural patterns. Nothing new, but what caught attention was the exact vector of 3i Atlas descent aligning with the Central Depression. A perfectly circular basin less than 3.5 kilometers wide. No known impact origin, no volcanic residue. Perfectly centered within this basin sits a deposit of crystalline silicates with refractive properties not found anywhere else on Mars. When hit by solar radiation, they emit brief pulses of infrared light in regular intervals. Most dismissed this as geological curiosity. But now scientists ask, was this basin a random feature or a beacon? A rendezvous point? And if so, who set the coordinates? The ExoMars Trace Gas Orbiter detected something else. A spike in xenon isotopes in Mars' upper atmosphere. At first, scientists assumed solar radiation, but the composition was wrong. This wasn't being added from above, it was rising from below. From deep fissures near Cerberus Fossae, one of the most geologically unstable regions on Mars. Seismic activity spiked. Temperature readings rose by 3 degrees Kelvin in subsurface layers. Magnetometer readings detected a weak but structured magnetic pulse repeating in intervals. As if Mars wasn't being threatened, as if the planet was preparing. Something inside the crust, dormant for millennia, began to stir. After Mars, the comet continues inward. Perihelion comes October 29th at 1:36 astronomical units from the Sun. The comet swings behind our star from Earth's perspective, disappearing from ground-based telescopes until early December. The outbound leg takes it past Venus, Earth, eventually Jupiter in March 2026. ESA's JUICE spacecraft attempts observations in November. NASA's Europa Clipper coordinates for ultraviolet spectroscopy. Each observation adds another angle about an object humanity will only see once. Parker's solar probe images the hydrogen envelope during perihelion passage. That hydrogen comes from water molecules broken apart by solar radiation. Mapping its distribution provides information about water content and outgassing rates. Unlike solar system comets returning on predictable schedules, 3I Atlas makes one pass and vanishes. After Jupiter, it accelerates back toward interstellar space on the same hyperbolic trajectory that brought it here. The opportunity to study this messenger lasts only months, a brief window between discovery and disappearance back into the galactic dark. Despite months of observation from the most advanced telescopes humanity has built, fundamental questions remain. The actual nucleus size stays uncertain. Estimates span 440 meters to over 5 kilometers. The source of extreme carbon dioxide concentrations lacks explanation. The nickel emission without iron defies models. The trajectory alignment with the ecliptic plane continues puzzling astronomers. Most puzzling? The combination of high mass and active outgassing without expected acceleration. Either the nucleus contains far more mass than its size suggests, or outgassing occurs through mechanisms not accounted for in current models. Early October 2025 marks the moment when an object older than our Sun passes closer to Mars than any interstellar visitor in recorded history. Every instrument pointed skyward from Mars captures information that traveled across light years and billions of years to reach us. Data about chemistry and planetary formation in a star system humanity will never see. But maybe the data isn't the point. Maybe the chemistry, the mass, the aligned trajectory, the astronomical timing, the Mars anomalies rising from beneath the surface all point to something science isn't equipped to explain yet. Not collision, not random flyby, but contact. An encounter that was always going to happen. A rendezvous 7 billion years in the making. After that brief moment, 3I Atlas accelerates back into the cosmic dark, carrying its remaining mysteries, leaving astronomers with more questions than answers, and Mars, silent witness to this ancient visitor, returns to its orbit. Changed or unchanged, awakened or dormant, we may not know for years, or decades, or until the next visitor arrives. Anyway, that's it for the video, folks. Bye.